Hey everyone, uh, welcome back. And today we are going to talk about right triangles and some of the special things that we're going to use about right triangles to solve physics problems. So first of all, let's take a look at a right triangle and think about a little bit of just kind of the background knowledge that we might want to have. First of all, you should know that the sides of a triangle are called the legs or sides. Sides is fine. And that the longest one is called the hypotenuse. It's a right triangle because one of its angles is 90 degrees, and the three angles will all add up to 180. So the first thing I want us to remember is the Pythagorean theorem. And the Pythagorean theorem is basically a way for us to find the hypotenuse, the length of the hypotenuse, if we know the other two sides of the triangle. Now, I like to think about this in like the context of a word problem, right? So like if I walk 3 miles to the east and 2 miles north, then how far am I as the crow flies from my starting point? I'm sure you've all had that kind of problem in a math class or a physics class before. And the thing that you know is that it's going to be less distance than what you walked, right? It's actually shorter if you were able to come back this more direct way instead of having to walk all the way over here and all the way up here. And the relationship we use to describe this is called the Pythagorean theorem, and it is fairly straightforward. A squared plus B squared equals C squared. So in this case, I think I said what, 3 and 2. So our hypotenuse would be 3 squared plus 2 squared equals the length of the hypotenuse squared. That's 9 plus 4 equals 13, and that is C squared. So C is the square root of 13. And you could put that in a calculator and get a decimal answer if you wanted. I will say there are a couple of sets of numbers that are what we call Pythagorean triples, where the three sides can all be integers and still hold true with this. And these are basically those special triangles that you may have learned in like a geometry class. And so the big one that a lot of people think about is a 3, 4, 5 triangle. And so in a 3, 4, 5 triangle, we have 3 squared plus 4 squared, which is 9 plus 16, which is 25, which sure enough is the same as 5 squared. Yay, check, hurrah. Um, and so that's just a Pythagorean triple because all of the numbers get to be pretty integers that are super easy to work with, and it still satisfies the Pythagorean theorem. If you're kind of a math nerd, by the way, you might want to look into Fermat's last theorem because this is a piece of math that kind of puzzled mathematicians for hundreds of years. And it has to do with the Pythagorean theorem and basically a mathematician saying it was really easy to show that you could do this for higher numbers than just squared. Like, could you do it for cubed or to the fourth or to the fifth? And he said, "Well, it's super easy to do, but I can't show it here. So I'll tell you later." And then like mathematicians for hundreds of years struggled to prove or disprove that. So look into that. It's super fun. There's lots of other videos here on YouTube that will tell you about that. All right. The other thing we want to talk about is trigonometry. And trigonometry is essentially the relationship between the sides and the angles of a triangle. So let's take a look at this triangle, and I'm going to label it a little bit for us. So we're going to look at one of these angles, which we're going to call theta. It's like a 0 with a line straight through it. Theta. And then I'm going to label the legs of this triangle adjacent for the line that is, or the leg that is right by my angle. Opposite for the side that is right across from my angle. And then, of course, my friend, the hypotenuse for the longest leg, which also happens to be right next to one of this angle. Don't get your hypotenuse and your adjacent mixed up. Adjacent is one of the two shorter legs. And so if you look at like any calculator from like a TI 30 on up, you've probably seen on that calculator these sine, cosine, and tangent buttons. Sine, cos, tan. And you may have wondered what they are. And what's interesting is that these are functions that tell you something about the ratio between two legs. So the sine of an angle is just the ratio of the opposite leg over the hypotenuse. The cosine of an angle is the ratio of the adjacent leg to the hypotenuse. And the tangent of an angle is the opposite to the adjacent. And so your calculator actually knows these numbers. If you type in like the cosine of 60, it knows the answer to that. And you can use it then to solve for these legs. Let's take a look at how we might do that. I'm going to take a triangle and I'm going to say I don't know the opposite or the adjacent. Let's maybe call them X and Y. But I'm going to say the hypotenuse is 10 and this angle here is 30. And by the way, those of you who remember that they need to all add up to 180 degrees probably could also tell me that that other angle then has to be 60 and you would be right. So I can actually find X and Y now because I know just that angle and 10. And here's how I would do it. So I would say that the sine of 30 degrees equals opposite over hypotenuse. Okay, well, opposite, what's opposite there is y over hypotenuse, which is 10. So y is 10 times the sine of 30 degrees. And if I type that in my calculator, I will get 5. I can do the same thing for the cosine. Cosine of 30 is adjacent over hypotenuse. So what's next to me is x over my hypotenuse, 10. So x equals 10 cosine of 30 degrees, which you'll get something like 8.66 on your calculator. There's a square root in there, hint, hint. And now we know all three sides of our triangle and all three angles, actually. And so this is something that we're going to use in physics to do what we call vector decomposition. Which is when we have something like, say, this 10 on the hypotenuse. Maybe it's 10 meters per second. And I know I'm traveling 10 meters per second in that direction. And I want to know, well, what does that mean? How much am I traveling horizontally each second? And how much am I traveling vertically each second? And I was just able, with a little bit of trig, to tell you that horizontally, that means I'm traveling 8.66 meters per second. And vertically, I'm traveling 5, also meters per second. This is going to be very important when we do two-dimensional force problems and when we do two-dimensional motion. And so I look forward to seeing you on those videos. I'll link them here when I get a chance. And have a good day. Thanks. Bye.